think it might be working. Is that working? Yeah. And I'll operate the camera. Yeah, I'll get. Don't worry. Don't go down on the knees. Okay. I'll adjust the camera. Okay, over to you, Alain. Well, I'll let you introduce yourself properly and.
Yes. Well, that was a fateful day in Saudi Arabia. So, I'm hoping we have more of a discussion than a presentation. And obviously, some of it is about BIM. And what I felt most comfortable to talk about is BIM in construction, because as you hear, that's where I'm spending quite a bit of my time. And so hopefully we can have an interesting conversation about where BIM is relevant in construction. I can share a little bit with you what we're doing. They're pretty reused slides, so I apologize. Some of it is just reused from a speech that or presentation we had at EcoBuild about the future of BIM was the question, and some other stuff is just copied from slides that you already seen, but I think it's interesting to have a different view on them. I don't apologize for that. Copying is the sincerest form of flattery. And then there are some other slides that I use to try to explain to contractors what we're trying to do. So that's hopefully going to be informative, but we can steer it whichever way you want. You are on the masters, and I'm just a student. So yeah, this is the first slide I reuse because actually our client, the contractors, and our clients, the owners, what they're interested in is on time, on budget, and built to design. And in the capital phase of a project, that project is $1.6 billion. That pretty much matters, right? Time is money. The weekly mobilization on that project is $2 million. You're 1 week late, you costed yourself $2 million. Zaha Hadid charged $15 million for the design, so you're 8 weeks late, you've blown your architect's fee. How do I move?
Oh, just the down arrow, I think, is probably the easiest.
So just to give you some background, so that hopefully you don't ask embarrassing questions that I can't answer. I'm not a Revit. I'm not an architect. I'm not construction manager or construction engineer. I'm just a guy that ended up running a company which is a digital studio called Statelier, and that's based in India, and which has its holding company in America. It had a brand for delivering BIM in North America since about 2005. Also holding this card of director for BIM for a company where we met in Saudi, is bringing consulting and BIM services to the Saudi market. And then personally, I answer questions on how might you be using BIM more intelligently. From my background as a business consultant, and you will see that I will not talk about design, and I'll talk a lot about money. I'm sorry, I don't want to boil it down to money, but it's what makes the world move forward. And those three pictures, giving directions, hence the that's Capstock, that $1.6 billion project, which we are deploying BIM for construction. So actually, I don't speak so much at conferences, etc., because I'm not talking about what we could do or what we should do, but we're actually too busy doing it, having headaches, with porta cabins in the desert, and 60 Reddit station trying to produce something out of the BIM that justifies the BIM fee. The BIM fee on that project is $250,000 a month. And so, and then that runs on a studio, and that's 5 Broadgate, the UBS headquarters, and doesn't it look pretty? And yes, this visualization was extracted out of the BIM, and the extraction and the BIM was created so that we could do make architect would produce the drawings. So we help create that digital data that sometimes architects or engineers need. So that's where I come to you from. So let's reuse that one. You all know it, but actually it sort of get me excited, because most of what we talk about in BIM, and correct me if I'm generalizing, is about here. We're talking about how we design a building better, and Revit and Bentley, etc. They're all authorship tools, and the software vendors spend most of their energy here. And it's interesting maybe to pause for a second and say, well, we said it's $20 there, $1 there, $60 there. Why are they spending most of their time here? And it's interesting, first, because actually here it already exists. People have not waited for the world to wake up to BIM, to have complex computer systems driving facilities management and building maintenance systems. Fact. So don't think that BIM is going to come there. It's already occupied. Why is BIM there? Well, in part because Autodesk sells software, and that's where the greatest number of seats are. So if you sell software, you want to find people that buy licenses, and that's where they are. They're not here. But, and this is where if you were to make a business case for using technology, where would you want to use the technology? Where are you going to optimize a process that consumes 1, or where you are consuming 20?
The 20?
I know where I'd go, right? If you say I use electricity, and I use 1 to light the house and 20 to heat the house, I don't go and install a complex management system for controlling my lights. That would spend all my energy here. I would put my effort on minimizing energy consumption. That's not really what's happening.
But what happens in the second stage is continuation of the first stage, really. So.
Well, is that so? Is that so?
That's what you learn.
Sorry?
That's what you learned.
Well, I would agree and disagree. I would agree that if you design it badly, you then build it badly, and then you can't manage it. That's absolutely correct. However, in itself,
yeah, of course.
In itself, if you are again looking at it from a business point of view, and you meet the CEO of BDP, and you say, "It's been great for you, the CEO of BDP. Is it great?" How is he going to measure that? Is he going to measure it in terms of my clients are making savings, the builders are building better, or my firm is better? Well, as far as his firm is better, he spent thousands on licenses, and he still charges the same.
If you look at using the time and effort, though, isn't
he? He's reducing time and effort by about 6%.
Well, it's not going to help him as much.
It's not going to help him much, is it?
No. But if he's only focusing on the short term and time and effort, you're spending 1,000 in the short term. Surely you think about long term as well, though.
You have that debate, but let's remember we are optimizing $1.
Oh yeah.
And he's saying, introducing that $1, I save 6 cents. You go to a construction firm and you say, let's procure better. The target of a consultant procuring better is 10%, 2 million. Not 6 cents, 2 million. So that's where, you know, from my angle, why I get excited, and I'm not an architect, is I'm seeing an industry, and I'm seeing a technology, and a good potential here for deploying the technology and having an impact. Interestingly enough, a lot of the people that could do that are in this room or sitting here. But they are looking at it from, hey, I could make a better design. You can. By the way, the benefits going to accrue to somebody else. I could make a better design, try to sell it. How much is that a better design worth? I thought your design was great already. Your drawings are going to be more precise and better coordinated. I thought they were coordinated already. So you are like, I'll make fewer mistakes. Oh, you were making mistakes. Good luck. Good luck. Yeah, the client loves it, and there's no doubt. But in business terms, you know, how do you maintain a sustainable advantage? You're buying into the technology. Your competitors buy into the technology. Everybody's standing still. The design is better, and the client thanking you very much for
It's
it.
more precise and better, though, isn't it?
I think is it not more just a case of you're not going to get work if you're not doing BIM? So it's not so much we're going to be saving loads of money or we're going to be getting this business, you know, this benefit, that benefit. For the BIM aspect, what's in it for me is you're going to survive, and I think that's probably the.
I wouldn't disagree with you. I wouldn't disagree with you, and you know, I think I'll move on a little bit, but I put this slide in because we spend a lot of time talking about this, the $1, and forgetting about the $80. And yes, then we say, no, I'm not going to forget about the $80, and my $1 I'm going to spend it so that, you know, I get some savings there. Brilliant, better design, definitely, and lots of benefit for the other guys, fantastic. But you have not benefited from that. Except, you know, as a Sterling medal winner, standing outside the building and says, it's amazing. It is. You may, you know, you're most likely poor and earning, you know, less than you could on an hourly basis at McDonald's. But it's a brilliant building. That's a bit, you know, a commentary on the business of architecture. I'm talking about BIM now, and bringing that BIM in construction. So the BAM. Why the BAM? Because the Boom, Massimo, Archibus, IBM Global Solutions, Accenture, Smart Cities, they're all over there already. Schneider, Systems, they're there, okay? BIM is data they inherit. It will make their solution a little bit better, but it's already there. So my theory, BIM too late, here too little, so let's talk about the BAM. So this is another slide I've pilfered from the future of BIM, and to try to share with you where I'm coming from. And I call the slide Joining the Dots. Actually, Sam is joining the dots. Sam was at university with me, not the same course. You know, so this is as much insight as a preface to why I see the world like I do. I started my life sailing, and that's why I came to the UK. Interestingly, look, that boat sailing there is doing about 40 knots, it's fully out of the water, it's completely carbon fiber. It's being designed with the most advanced technological tools available. I was doing this about 1985. Right? So if you say hey, BIM, what is it? Well, it's a design tool for designing an object and optimizing it. Guess what? 1985, I was simulating full-size structures, racing them, and determining which one was the better one already. And that's sort of, you know, maybe a first insight saying actually this is not new at all. This is old stuff. I'll come back to this one in a minute in the same book. Then I actually, because these things are designed like these things, you can see why it's flying. I actually spent 5 years learning about designing these things. These things are designed, constructed, assembled, and managed fully in the digital world. Okay, to a point, you know, I mean, just Google it, research it. This industry went through the digital transformation 20 years ago. Every single aircraft is separate. Okay, it's different, every single one. Because every time you build one, you've learned from the last one. It's up in the sky, its digital instance exists in the computer, it's talking to the digital instance so that it can at all time work out what's happening to the aircraft. So that when it lands, they already know what they need to fix, maintain, repair, turn it around quicker, time on the ground, not earning time. So again, we'll revisit, but you know, it is possible in the oil and gas industry, in the nuclear power station industry, in every industry you look around that make big things, big expensive capital things, they're using digital. Why aren't we? Why do we think we are new and revolutionary? They've been doing it. Okay, they have more money to pay for it because if you build it too heavy, it doesn't fly. But you know, they debug the problem. And it's really interesting. We can already, you know, anticipate a little bit. Their supply chain is really interesting. You know, talk about design and build. Boeing, in this case, I work with Airbus. They buy systems. Like you don't buy a lift these days, you buy people movement vertical device. Yes, you tell them, got so many people on so many floors, please provide me the lift that gets these people on that floor. Right? That's what you buy from Schindler Lift. They buy propulsion systems, they buy landing systems, they buy seating systems, and all those things are designed by separate entities, which are then brought and assembled into the digital domain, and then created and then assembled in the real world. So all the integration is done in the digital domain first. That's why they can make that in Belgium, that in Germany, that in France, that, this is Airbus, not the Boeing one. The wings at Filton in Bristol, the Rolls-Royce engines in Derby. And it all comes together, and that's what it flies. I then spent some time in the automotive industry. You know, there's a picture of a car. We were having just this simple conversation. Again, there's a lot of things we can learn about what these guys have done in terms of enabling the digital supply chain. Why? Because, and once again, every single car is different. Yeah, if you build an X5 and you calculate how many different ones you can build, it's about 20 million, and customers order a different one for you know, this seating, this color, this glass, this railing, this wheel, etc. Every single one pretty much is different. They're built to order. So you can imagine that they've really optimized themselves to have a really good digital model that allows them to validate a configuration is going to integrate, and then get it at assembly point on time. Okay, so I work in the automotive for Michelin tires. So you supply cars, 4x4, well no, 2x2, because the front one and the rear one are different, at the assembly line for that car 20 minutes before the car arrives. They don't want to know about the tires. Before that, they don't want to know about the tires. After that, they'll ring you and tell you you've stopped my assembly line. So they've synchronized their supply chain simply by data enabling it. Why do they do that? I hate to mention it, it's money again. You want a car to be sold to your customer. If you can build to order, their target is the 3-day car. So they build it to order, so they have a car goes from factory to customer in 3 days. Pre-digital world, Volkswagen UK had about £1.5 billion worth of stock in the UK. Post-digital enablement, they had about 300 million. The cost of capital to Volkswagen is 10%. They save themselves £1.2 billion, or £120 million recurring on financial costs. Now we can talk, right? That's why they do it. That's why they look at digital and say, can we do a better design? Yes, you can, of course. Can we save 120 million pounds from the UK business? Oh, yes. What do you need? A digital model. Let's get that. What else do you need? Oh, a digital supply chain. Fantastic. Let's get that. You know, they spent 25 million pounds on it. Did they blink an eyelid? No. Does the designer come in and say, oh, boss, I like it. There's a new tool, and I think the car is going to be a little bit better if we simulate the reflectivity of the windscreen. You can see the purchase requisition, and again, you want to spend what on your design? $500 for that extra license. Is the car really going to be really better? Yeah, I mean, we're in the BIM world again. This is the BAM world. So that's how I put all that together, and then we create this model of the research center in Saudi where we met, because the business cases that we are trying to attack with BIM are this building's 1.6 billion. And there's another slide I haven't got, but I would reuse. You know, efficiency in the construction industry is horrific. How do we know that? We've seen the efficiency indicator, the economic indicator that has shown over the last 30 years a complete degradation of efficiency. The buildings have become more complicated, and the supply chain hasn't been able to cope with that. The designs are more complicated, and we've not been able to resolve them for all sorts of reasons. One of which being probably lack of digital enablement and revisit of the supply chain. You know, conservatively, you and I know that once we finish building it, we know how to build it 20% cheaper. So that's $320 million cheaper on that building. How convincing do I have to be? So, we all know these things cost 300 million more than it should. Can we try to build it a little bit cheaper? Little bit. Yeah. Let's try, right? Especially that you already coming with all the BIM arguments, be beautiful, it'd be better, it'd be more, or this or that. But I'm coming with a pure argument. 300 million. Let's attack that. Totally measurable. That's what we're targeting with BIM in construction. I better. So, you know, our government, I think, is saying the same. It says, okay, let's design it better, level 2, integrated BIMs, you know, collaboration, etc. And then they're talking about, you know, ISO BIM, IBIM, life cycle, data management, etc. It's definitely into that space. That's what the government is, I think, talking to us about, or sort of anticipating. What they're expecting is, once you've taken the first step of moving the design into the digital domain, hopefully, the more adept contractors are going to say, hey, if I build it in a factory, I can build it 30% cheaper. If I build 30% in the factory of the building, that's 10% of the capital cost.
From what you're saying, I perceive you look at BIM as something that designer use to do this design. Is that it?
I'm saying BIM is a tool that can be used and being talked about being used in the design phase, construction phase, and operating phase. And my focus is in the construction phase, and obviously there are a lot of benefits that accrue in the design phase as well.
Yeah.
And so they can be, they definitely can be used in the design phase.
Because from what we are not trying to, from what we are learning, maybe you are focusing on what the architect received from using the BIM, but we learn about how the BIM improves the whole process rather than how it influences the design. So when we talk about design, it is not about how it visually is. It is more about how efficient it is going to be as well, and how easy it is going to be to construct it, and how efficient it is going to be in the after use.
Absolutely. And
but
which is
I get your point that the BIM should be a tool that the client primarily use so that he benefits more rather than the architect for his design.
well, I think we're saying the same thing. The benefit will accrue to the client.
Yeah.
And in the design phase, you can build a lot of design for manufacture and design for constructability. My point is, how are we going to get serious about this? And how are we going to actually measure the returns we are getting? And where are we going to get, for example, some of the feedbacks in the data? I'll continue and say, I think this is probably a little bit, this is a very, very quick, and I think this you've seen hundreds of times. But when we try to explain to a contractor what we will do, if we start talking technology in BIM, they sort of glaze over. And why would they not? It's like you go to a businessman and you talk about Excel and spreadsheets and clever formulas, and you're going to be able to, they want to think about it in terms of maybe services and outcomes. So we talk about using BIM rather than BIM services, and try to focus on some of the things that today we can deliver using the technology, and some of the other things that we'd like to deliver and that everybody's still struggling to. But the BIM view of the world, this is my BIM view, is that at the heart you put a digital PMO. Contractors understand PMO, or the project team, and we certainly can review and validate what's going to be built in the digital domain through visualization. Then you have the virtual construction bucket, and there, what we are talking about, I think, is what should happen in the design phase is getting the design coordinated. Okay, and there's no doubt that BIM as a tool in the design phase is helping that a great deal. It's very surprising quite how much uncoordination still is. Why? And why that should be is probably, and why this will continue. As we know, the consultant provides design intent, not a construction prototype. Two different things. Second, when your team is actually creating that digital model, a digital model is constructed for a purpose. And the purpose today of a design BIM is to produce drawings. Revit is a fantastic machine at producing drawings. And what you check is the drawings, not the model. It's the drawings. And then you could say, I'm going to schedule things out of that model. And you're going to check the schedule. And if the drawings or the schedules don't work, you go back to the model, change the model until your drawing and your output comes out right. So for me, that's the absolute proof that you're not creating a digital model of the building, you're creating a digital instance that allows you to extract better drawings and better schedules. But if you take that digital instance and say, let's build it, you can't. You can't, and you've not been commissioned as a consultant to provide that, actually. You've been asked to provide design intent drawings with a model for reference that they can then optimize for construction. And you know, that's the very much the next step. What happens into this box is we work for constructability on a real digital mock-up of the building. We try to create something that's much more constructible and a much deeper representation of what actually will be built. Because once you've done that, what our clients in the Middle East love is the production of the shop drawing. Now in America, they want to get rid of the shop drawings altogether, and that would be fantastic. But in the meantime, so much money made by the executive architect approving the drawings and the local design consultant rejecting the drawings, that's, you know, it feeds a whole industry of people. So it is not going to about to disappear. But obviously, now if you're thinking about it in the way I'm saying it's a digital process, one of the outcomes of the construction is we need shop drawings. And actually, when a contract is placed today and they want a BIM approach, this is one of the gates that they put in. They say the shop drawings will be produced from the BIM. So they don't say you will use BIM, they say shop drawings will come out of a BIM. And that's the gate, and you don't go to site until you have the BIM. So that's one service. Then there is 4D BIM, and again, you know, linking the planning to the construction model is of no interest whatsoever. It's pretty, it makes a picture. What's of interest is, can we build that thing faster? Yeah, because it's your weekly mobilization costs that are going, and if you've not got your gangs coming in the building at the right time, or if you've got people sitting idle, or you've got your gang and you don't have your materials, that's where money starts to flow. And you know, a planner knows where his problems are going to arise, so he allows for. But how does he control it on 2,000 people? Type of project. So we want to work actually to get a better plan, or to work with the technical team on how do you actually assemble that data room or that chiller room. Okay, chiller rooms are built typically 2 or 3 times. The world record, I think, in some hospital in Riyadh at the moment stands at 8 times. They just couldn't fit it in. You know, they build it, they build it. So why not sequence it? You know, you have the model, build it digitally until you get it right. Okay, I'll show you some photo of what aerospace does. I mean, they've been doing this for yonks. This one is an area where there is the money. So we're actually working in that area. It's not yet. It's one of the areas where things are still struggling. Because remember, we all started with a design BIM where all we wanted was something that produced good drawings. And now we're going to say, but that window, we're going to buy it. That window. So just mentioning over lunch, how do you make sure that every single window is actually a window? You say, I want to buy the windows, give me the windows. All you've checked so far is that in the drawing there is a thing that looks like a window. It may have been tagged as something else, but looks like a window. You need to make sure that your data integrity is right. But once you can drive based on the plan, MBO items into your, that coming from your digital mockup, you can start driving your supply chain. And of course, driving the supply chain is one area where massive efficiencies have arisen in all other manufacturing industry. And don't tell me that because you're building a one-off, it's all different, like if we were building multiple oil rigs in series. We don't. Or aircraft carrier for that matter, or submarines. We don't. Okay, so we create a bill of material, we push it into an ERP system, and then we drive the whole supply chain around it. Why do you want to do that? Because what matters most to the developer, what's his most precious commodity, is dollars, is money. And you know, his whole optimization of his project and his scheme is how much money do I consume and need to have until such time as I can start selling the thing and get paid, right? So if he says, oh, just to be sure I'll order these bits and get the windows, park them over there, we've got them, we won't be delayed. The next bit, you know, you should spend, what? You should spend $5 million on windows? 2 months early. How much that's just costing? And it's just, yeah, I mean, and you think about the mentality of the contractor, you send them a quote, they want 10% discount, they want 90 days extra terms, they're just like cutting every penny. But then they order windows, put them in the corner and let them rot. It's just, you know, to somebody who's approaching this bim bam boom and looking at digital and saying, how does the rest of the world does it? It's just like 1970s Ford Magnum. And then eventually, you know, the data ends up into the facilities management. We've created and generated a lot of digital data. And we want to use it in the ongoing operation. Like we want the system to inherit it. But let's not, you know, in our great BIM enthusiasm think that we're now going to do BIM for FM and Revit's going to have, you know, census data coming into it. It's going to be just like, you know, you've read too many Autodesk brochures by that time. Okay, so that's what we are playing at, and I think there's nothing fundamentally new. You know, these are the drawings that you've seen. These are the visuals that we can help stakeholders with. Getting you know, getting the remeasurement and the planning in sync with the fourth dimension. The shop drawings, they love this. They love this. I mean, the economics of this is horrendous. You know, one of those costs $250. That sheet costs $250. Has to understand that $250 a drawing. I mean, you and I know that if the bin's configured right and we've done our job right, you know, press the button and and half the job's done. You know, create some more blocks here automatically. You know, we do all this manually. But if you talk to the retail guys, you know, they optimize everything. So some of our customers in America, they've optimized this to a point where, you know, they produce shop drawing for their store layout, and their store layout changes. So you can imagine they've got pretty good at, I need the 50 drawings to be reissued with the new store layout. All these blocks and data, etc., is automatically populated. It's just a production engine, you know. And so you go from $250 to $2.50. It's that kind of transformation of production of information. Yeah, and you know, we're like, you know, handwriting every books, like, you know, we've not met Gutenberg yet. So this was the big one, where I see a lot of potential, but a lot of challenges at the moment, and it's BIM at the data level. It's making sure you have all the data and making sure that you are starting to be able to accept data from your manufacturer, accept cost data from your invoicing system, and put something that is investment grade into the machine. So there's obviously rubbish in, rubbish out. So now you're talking about millions of dollars that are controlled through this system. Suddenly it's getting a little bit more tense in the room, if you see what I mean. So, in summary, the client view then of BIM, and what they definitely want the design optimization. We talk about that a lot. Design audits, BIM coordination, digital mock-ups, renders, etc. But then what they are expecting is, just get my shop drawings, get that data out. It's just digital production of data. Manage my timescales, optimize, drive my supply chain, manage the costs. So here is manage my plan, here is manage my supply chain. It's huge, huge area. And then hand it over, help me commission. That's their view of BIM. They're not interested in whether you're using Excel, Multiplan, or any other flavor of technology to produce your data. They are interested in outcomes. Is that? So, what's interesting is if you then move away from a single building, and this is a real project we are looking at in again Saudi Arabia. They have 21 building types and 7 sites. In fact, that's not quite right. I think they have 100 odd building types and about 45 sites. And on each site there are about 30 buildings. But they've only given us part of it. So we've only got 7 sites, 21 building types that repeat, and about 120 buildings to build. And the idea is, can we use digital in all these services we were talking about, push it through a digital engine so that when you buy, the traditional approach of building this, right, would be, okay, I've got 7 sites, I've got 7 site managers, I've got 7 site managers, I've got 20 buildings, let's design each building. I've got the concept design, now I have to make the construction drawing, the shop drawings for that site, etc. And we would have had massive amount of replication. Absolute massive amount. Whereas if you can manage the information in the digital domain, which has become possible because we're using BIM, you're saying, well, I've got 21 bonds, I've got some interfaces to manage across my 7 sites, I've got 1 supply chain, for 25 things, it's got just 7 delivery points. 7 delivery points. I mean, which an ERP system will have 30,000, 40,000 delivery points. Okay, bill of materials 21. The ERP system could swallow another 20,000. Each building components, the SKUs to manage about 400, 500 maximum. Typical aircraft, 100,000 parts. In terms of complexity of data, this thing's being swallowed whole for breakfast by most systems employed in other industries. It's just we need to configure it. And we need to have a business case that delivers to the money we're going to spend. Because, yes, we're going to switch this thing on. The total build cost on this is $450 million. It's not that big because each building is simple. Again, it's Saudi, just to give some context. They don't have any infrastructure for their government. Like we have fire brigades, and fire brigades have got lots of fire stations and then a fire brigade control station. They don't have any of that. So, civil defense needs 45 central command, training room, a mosque every time, car park. They need to build that at an industrial scale. And I don't think that in the UK we're not that different either. I mean, we need to build thousands of schools. We just didn't do it that way. We approached it a slightly different way. I'll come back to that. But so that's the idea. So we've been going for an hour, so probably we need to give ourselves a breather. But these are some pointers, and it comes from the future of BIM presentation. Where there is a business case to use digital is used. So let's have a look at what other industries use. So we've touched upon the aerospace, the supply chain, the assembly analysis. All that is very understood. So what do they do? Well, actually, all the big guys of consulting, they're there doing analysis. So this analysis I reuse is from Atlas Consulting. And they just looked at the digital services that are being deployed in the aerospace and where they are. This is quite old, 2012. You can see business impact, how far away on the horizon, and where it is. And I've picked 4 to try to put these in music. But I mean, it's worth trying to read the slide. That's totally unreadable. But I'll try to read it. So things that you can do that has really low business impact, like social networking. I don't know what that might look like in a building, but it will happen that I like this building, connect with the architects, give your idea, give your feedback. It's going to happen. E-books, we've saved lots of paper, probably. So RFID there is tagging every single piece with a unique, remotely readable tag. So it's very relevant to the aerospace industry because anything that goes into the plane has to be tagged so that you know who's messed up when it falls out of the sky. I don't know if you've always been amazed. It's like Concorde goes crashing and they tell you the birthday of the guy that made the car. That's because they use things like RFID. And one that you will have learned about lean management. That's big subject. I mean, I love lean management. The industry could learn a lot from deploying it, and I'm sure people will make fortune in advising construction firms and chasing efficiency using lean. But let's focus on some of their green dots. So all the white dots is things that they've done already, like e-supply chain exchanges. Every single thing that goes into a plane, they don't like, I'm gonna need to put bathrooms in this building. So yes, that's sink. What did the architect specify? Yes, that's an acceptable replacement. Create a RFQ to the 5 suppliers that I need. Send that into a triplicate validated order from procurement. Receive it. It's just like, no. You push out the fact that you need your bathrooms, and you let your suppliers bid against the understandable spec that you've just pushed out. And then you say, that's the one I want. That's why I selected it. Send it up for approval. Place the purchase order. Ask the delivery date. Agree the credit term. your expense and your capital spend profile updates into your ERP. It's just that's how it happens in the rest of the world. I've procurement directors, they just get massive piles of paper and they're just signing it, and you can see the clerk down the road retyping it into the spreadsheet. I mean, it's just like the world of construction runs in Excel. So e-services, a couple that we've picked out. Cloud collaboration. Now we're going to have a lot of data, and we want to collaborate. So that's definitely something that's going to be relevant. E-supply chains. I've highlighted two areas. One, there's so much to be procured. It's so task and time consuming, so high impact if it's not there. But more importantly, once you have a list of something to buy, you can buy it better if you've got confidence in it. And I don't know why it said 11112. I tend to say thank you, Bill, when that happens. Voice of the customer is an interesting one. You know, how do you integrate feedback into your design? And I think that's an important one. And then Internet of Things, because we were talking about the future, so we had to drop in some. I'll show you, because buildings are things, right? So, cloud. This is emerging.
Is that M6?
Yeah.
Yeah.
So, but I think the concept is absolutely clear. Is that the data goes into a cloud, and the cloud has functionalities to index it, etc. I don't know if you use Dropbox. You probably all do. I love Dropbox. You never lose the last version of your presentation. Imagine you doing the same with your BIM. Everybody's collaborating with the right level of access, never lose the data, etc. So your contribution are data streams going into your repositories, and then all these services that I was talking about, they become apps. And because they're collaborating on top of the cloud of data that is managed industrially, that's where I like the guys at M6. You can see they're bringing 6 apps to make it useful already, but you can imagine thousands of apps. We're developing an app for procurement. Surprise, surprise. Because we want to just reuse the cloud approach. So in our business model, all the data that we are receiving, we want to turn it into BIM data, push it into Vero, and it lives there. It's indexed in the archive. And then we mine it. We then use it to deliver our service. So each service becomes an app. That's the cloud.
Do you play with Vero?
Yes?
No. Oh, no, I haven't played with it yet. So
it sort of works.
Yeah.
I don't know. You familiar with Veo? It's a nice piece of software from a firm in the US. Have been developing it 5 years. Been that hard to make it work. At the heart is the concept that the digital data relating to the construction is going to be hosted in a cloud that understands BIM data. Okay, so that's why I'm throwing, this is a version of an e-supply chain where the construction data is in a repository called M6. Now, once the data is into a repository, you still achieve nothing, right? I mean, except maybe permanence and access. The killer app for them is these little apps that I was putting on top. So they've archived the data. Then Logic. So Logic is Solibri or Navisworks, but Navisworks in a cloud version with on steroids. And of course, it directly competes with some of the Autodesk technologies. That's why Autodesk put $5 million into Veo. Just to make sure, that they are there, and if their programmers don't get it right, the Veo guys will.
One of the guys used to work for Autodesk. The guy who actually set it up used to work for Autodesk.
Yeah,
They're all interrelated.
we're all cousins, I think.
It's quite incestuous.
So what's once you think about, let's put all this data that we're generating into an environment where it's understood as BIM data, then it becomes very powerful. You can rewind it, like the time machine on your Mac. I don't know if you use that. It's fantastic. What was the state of my Mac 6 weeks ago? Wind it back. Yeah, that's what you can do in the cloud. Infinite storage, because we don't consume much data. I mean, it depends who you ask. If you ask Revit, is this building big? It's already struggling, what you want to do? What? Four stories, full spec? No, you must be joking. The data models are wrong. But if you are in the real world, not the Autodesk world, then is this going to be recorded and played back?
I can delete that bit.
My friends at Autodesk are going to kill me. But, it's not a lot of data. Not a lot of data, especially if you're actually storing it differentially. But it's going to struggle because the data formats, they are, what's a window? We say it's a window, but how have we tagged it as a window? Is that understood as a window? So, this is where, IoT is doing a lot of work, but then we need to then put that into our systems and be able to actually look at all these binary bits of data as information. And once we've got that, and I think that's where it's heading, we will be able to have this concept where everybody's streaming their information into that platform. Not, I save my files, I publish it to Bus so you can download it, and you've done was it BIM Qatar?
Build Qatar Live.
Build Qatar Live.
How'd it go with that?
We are doing it actually for one of our models. We are developing the process of Build Qatar.
So data exchange, data collaboration becomes a major undertaking. I know I've got on that CATSAR project, it's a complicated building. There are 5 main buildings, each subdivided in cells. And you can immediately see, we've got architecture, primary steel, concrete, secondary steel, facade, high voltage, low voltage, comms, drainage, chillers, all the MEP, all the mechanical systems, all the HVAC systems, a few more research systems, security. I think per building we have 12 or 13 different disciplines, what we call each files, and because the files become heavy for each of the 5 buildings, we have segregated them into four zones. So 5 times 4 times 13. How many different files have you got? And then you upgrade, you update, you change, you coordinate, etc. You generate, just keeping track of what file is what. It becomes a massive undertaking. I thought we'd done away with the concept of files. About when was this launched? It's gonna have to change. In the digital world, we don't open file. You don't log on your API system and open the file called orders from my customer in March 13. It's just not how it works. It's the data there. So procurement. What we need to be able to bring together are the e-supply catalogs and such as those. People that are developing these libraries like Seek and BIM Store, etc. What they're developing is e-supply catalogs. They don't even know they're doing that. They're discovering they're doing that because you know, we put a picture of the geometry, but what's much more important is the information that underlies it, and what actually the first question that we get, well, first or second question, you know, if you go and see a manufacturer and say, why don't you have some Revit product libraries? If he knows about them, and they increasingly do, then they say, you know, will I increase my specification rate? So that makes a business case. But if they don't know about them, they say, will the person be able to order it? I put it there in the digital, can they order it? You know, it's like, I order from Tesco.com. There is the digital representation of the bottle of milk. Can I do the same with the light bulb? Why not? It's a light bulb, bottle of milk. What's the difference? You know. What's the size of the construction industry again? $6 trillion worldwide. There is going to be supply platform. Once you link that to your BIM data, to your enterprise data, and your project data, you say, welcome to the 21st century. You've just made it to where automotive and aerospace were in the year 2000. So I'm not saying that we're going to revolutionize anything. We're just going to do in the construction industry what everybody else has done. We have new challenges. We have specific challenges. We didn't have BIM till date, so we didn't have a lot of digital data. But now that we do, let's get on. Because then we'll be able to do exciting things. So there I go back to the voice of the customer, in a sense. The customer here is François Gabard. He's just gone around the world in 78 days. Single-handed on a 60-foot yacht. I think it's pretty amazing. I don't know if the next slide explains how he's done it. Yes. Well, it's all in the digital domain. Absolutely. And I think this is back to the point about BIM pervading all the way through, but we need to have the feedback. So this is generation 3 of that kind of yacht. They run the race every 4 years, and so the data they collect while they're racing gets back into the next generation, etc., etc., etc. So that feedback is very, very important. I wanted to quote, Sir Francis Chichester. He went around the world in 200 and something days. Okay, that's not fair. So we'll move on to that milestone. In 1990, don't quote me exactly, they launched something called the Jules Verne Trophy. And the Jules Verne Trophy was who would sail around the world unassisted, no, nothing to do with it, just sail around the world in less than 80 days. Right? Because at that time the fastest time was about 120 days. It seemed completely unbelievable. So they built these massive things, like 120 foot long, twice as long as that. And they went at it like, and they did it. They got round on a massive catamaran, 105 odd feet, crew of 15, 80 days, 79 dot something days. Blow me, this guy's just done it alone on about half the size in 78 days. What's going on? What's going on is we're applying a bit of good old digital technology. They went to see Dassault that built the aircraft, so they built the boat like that. The boat is fully instrumented, so as we know, they know where everything is happening at all time. So you embed fibers, optical fibers into the carbon fiber. The frequency response of the optical fiber changes based on the stress it's under. We have that in buildings all over, right? Sensors, where are people, how hot is it in this room, etc. It's already, but they use the data. They know what the worlds look like, pretty much like that. You know exactly what the weather patterns do typically. So you build a boat digitally. You send it around the planet digitally. You then find out how long it took. And then you say, let's change the design, and then let's do it, and let's change the design, let's do it, etc. You know, ETABS modeling, crowd modeling, you do it, then you build it. You build it, and then you realize that what you thought was going to happen, because you measure it, is not actually happening. Because we don't live in the matrix, we live in the real world. So that gets iterated, put back into the model, etc. And in the end, you go from 120 days, fully crewed, massive things, to 78 days. And that is design optimization in the digital domain. And I think that we've only just seen the beginning in the construction industry. But we need to get involved with the construction phase and the use phase. Kobe spreadsheets probably not just enough, but what they've done is connected the digital domain of the construction phase to the design phase, and likewise the use phase to the construction phase and the design phase, and you know, work seamlessly and try to create data sets that they could, you know, build. And it's really, you know, beautiful to see the optimization you can get. Formula One does the same. Oil rigs do the same. Planes do the same. Cars do the same. The biggest program in the car industry is measuring rates of returns, getting data back from the engine management systems, optimizing that, changing your manufacturing process. You know, once you have digital data, it's fantastic. I could mention supermarkets. They're the world expert at tracking what consumers do. And if you want to look, you know, in things that could pay for this, interestingly enough, retail is probably a good area, and I think you've already had the talk.
James Brown, yeah.
That you can have interesting things happen when you plot retail area, Facebook campaigns, and revenue per square foot on the floor, the actual revenue on that rack, and see what happens to try to find areas. They say, well, these kind of customers had a viral going, it's on that brand, and in that store I did it in that space, and in that store I did it in that space, and my response was different. That's the kind of, you know, voice of the customer coming back. Why do these guys do that? Because, you know, dollar per square foot is their life and blood. They're doing it into the built environment that we've designed. And then Internet of Things, you know, how are we gonna start communicating with our buildings? That was on my shopping list for my new extension. I will report. You know this thing, it's a consumer product. It's what large energy provider are deploying on a grand scale, but this is on a small scale. So this is your thermostat. You know, it's in Fahrenheit because it's an American product, but you know, it just looks a little bit sexier than your average thing. However, it's on Wi-Fi and it's measuring what's going on in the house, and it's trying to optimize just all by its own the energy consumption by noticing that you know, on Friday nights you tend to go straight from here to the pub, celebrate with your friends, so there's no need to heat up the room. And however, he wants to give you the control that if you need to heat up the room, you can do it. So it does that kind of thing. The buildings are becoming intelligent. in very much that same way. So if you know who's in the room and who's not, you can switch off the lights. Only if you've got the sensor, the intelligence, and the motivation and the business case to do that. The energy consumption, especially in zones of the world where you have to cool the buildings, each of us, we're a mini, power plant creating so much energy in the room. So to keep this room cool, it should have switched itself on to ramp up a bit of aircon, but it should have offset that by switching off David's office. It doesn't do that, but if it did do that, the business case would be compelling. The people that are deploying that business case are people like Schneider Electric and Siemens, etc. That says, well, give me a digital model of your building, and I'll see whether we can optimize your energy footprint by making the building intelligent, which is that kind of thing. We definitely have gone through. So that was, I think, where I started. I think BIM is only the word that we use when we come from design to talk about digital. Digital application in the built environment is called BIM. But let's not limit ourselves to the Autodesk brochure. Quite to the contrary, let's be good copier. Let's look deeply at what others have done, what others have learned. They've made a lot of mistakes along the way. They've faced a lot of naysayers. They've gone down the wrong track. A lot of, let's understand and reuse what they've discovered, and see wherever we are, whether we're in the BIM bam boom. Let's see what they're doing and use that, because they've really achieved a lot in the digital domain. This relates to a segmentation slide that I've deleted. But ultimately, I think there's going to be, in this BIM thing, there are two camps that are valid position, but I think that it's worth excelling, whichever one you pick. One is a guy that's called the Digerati. There it goes. So this must be consultant speak. And that's the guy that says the digital world is with us, and let's make something of it. Let's not talk about it and it's exciting and I have the latest Samsung and whatnot, but actually doesn't know how to switch it on, or accept the digital thing for fashion purpose, but actually look at it and say this is an opportunity to make something different, to change the way we do it, not just how we do what we do now, but how we do it. So change what we do, change how we do by adopting the digital, and I think that's certainly worthwhile. Hence my focus on the construction, where I think we can change more than how we do it, but what we do, so that we get some good returns for the technology. Or conservative, it's also, it says, okay, this digital thing, people drive more than cars, and great designers will remain great designer, just sketching and understanding their customers and proposing really amazing solutions. I think both camps are valid, but don't be a digital, talker and not a doer. Either embrace it or embrace another type of skill, as it were. That would be my conclusion.
Alan, thank you very much indeed. We've got time for a few questions. There usually are a few. Yep. Oh well, there's a couple.
I've told you I'll not say anything. So.
All right, you're not going to say
I've
anything.
got a quick one. You know when you on the slide of the yacht where you were saying design iterations and let's sail it around the world digitally and see what happens and then tweak something, then sail it around again and then tweak something and sail it around again. It seems, I'm really excited by things like that. I think it's great, but it's almost like we're trying to bash a round peg through a square hole and then change the shape and then try and bash it through the hole again. Why can't or how long do you think it'll be before the systems, rather than having a quick tweaking every time, how long before the system just says this is the most optimized design that you're ever going to be able to achieve, rather than trial and error or trying.
Right. Well, that's quite a deep question. There's first this one, right? If we put this in terms of a building, let's say we talk about the crowd response of the building. What we know is that fundamentally crowds are chaotic systems, and so we can't really write an equation, deterministic equation, that says where everybody's going to be and what everybody's going to do when you shout fire. Okay? So in the same way as we can't tell what the weather system is really going to be. Okay, so what they do is they raise the boat around the design of the boat around that planet on years of data, and then they look at not what is the design that answers that point, that weather system, but which one overall has the best response to the input that we can provide, and we excite it with a range of input to try to see that it doesn't fall off somewhere. The one that's exactly right, but if that anticyclone moves south as it did in 19 something, and you lose the race, that's probably not. You'll be able to start exploring trade-offs. So therefore, the reason why numerical exploration of the design space is required is that you can't deterministically find the precise answer, or not easily anyway.
Because I suppose it's not just with things like this. It's often baffled me why in structural analysis, a lot of packages, again, you'll try a design, and then if it fails, try something else, and then if it fails, try something else. It just baffles me why the system, we're still in the digital world here, and we haven't entered the real world, why the system just can't do it itself and just, sit away until it's found, right, okay, this is the best solution.
So I'll answer it a slightly different way. We can write absolutely precisely and completely the Navier-Stokes equation that describe flow around an aircraft wing.
In a vacuum?
No. If it's in air, okay, with infinite boundary conditions, yes. And now we have to solve them. Now, if the wing hasn't got a nice nice shape that mathematically is simple to solve, like a circle, well, guess what? The equation is impossible to solve algebraically. So you have to solve it numerically. And if you're solving it numerically, you have a number of numerical techniques to do that, but essentially most of them are minimizing differences. So you have a seed solution, and then you gradually iterat to reduce the imbalances until you find, within the precision of the machine, your solution. And is to make that not in. You are hoping that actually you've converged towards a real solution, and that while it was computing, you haven't introduced instabilities where the differences, instead of reducing, increase. And the final point is actually you've assumed the boundary conditions because there's no wing actually flying in perfect air with nothing around it. So the philosophical answer, Henri Poincaré showed that in purely describable mathematical system, there are such systems which cannot be solved algorithmically, doesn't work, algebraically, but also they won't tend towards a final solution. The disturbance, a tiny disturbance in the input condition will amplify. And so it's fiendishly complicated. Actually, once you've written it, you numerically solve it anyway. So you do finite elements analysis, and then it's an approximation.
But rather than using the brute force technique as what that can be used, you can use that algorithms for risk management as well, though, can't you?
You do use, behind that, you then get a set of solutions, and those set of solutions are
but in construction, it's still brute force.
At
the moment, isn't it?
I wouldn't say so. I think the returns is what drives the investment. So ultimately, if you can solve your problem by either putting another half a ton of steel, or you spend another 30 man days of engineering effort, you make a quick returns analysis and say put more steel, right? But that balance between put more steel and design more is always changing. It changes because every 18 months we can compute a lot more for the less. And second, we get better visibility of the return we could get from better design, because it tends to be self-reinforcing. If you put less steel, it's less heavy, so even less steel, etc. You have to have the confidence, but you can. And then you've got all the other external forces, which is, well, who's going to take the risk? We've already built it that way. I get a nice cut on the steel. Who knows, right? But I think it changes, and as you saw in the case of the multiple buildings repeated across multiple sites, obviously, if you're going to build something 20 times, you can spend 20 times as much on designing, because you get the returns 20 times. Fact. So it changes.
Okay. Okay. Is that another contract come through?
I wish.
Well, once again, thanks very much, Alain. Sorry, Claudio, you just walked in right at the end there. Timing is everything.